Welcome. Today we're diving into the world of traditional databases, focusing on how they structure and store data. Databases are the backbone of modern information systems, helping organizations manage, retrieve, and organize vast amounts of information efficiently. Whether you're a student, a tech enthusiast, or someone curious about how your favorite apps store your data, understanding traditional databases is essential. In this video, we'll break down the core concepts, starting with the basics and gradually moving into more detailed aspects of data structure and storage. Let's begin our journey into the heart of data management. Database is essentially an organized collection of data, typically stored and accessed electronically from a computer system. Traditional databases have been around for decades, forming the foundation for countless applications and services. They allow users to store, retrieve, update, and delete data efficiently. Think of a database as a digital filing cabinet where information is neatly arranged for easy access. This organization is crucial for businesses, governments, and individuals who rely on accurate and timely information. Next, let's explore how data is structured within these systems. The core of any traditional database is its data structure. This refers to how data is organized, defined, and related within the system. Most traditional databases use a tabular structure, meaning data is stored in tables made up of rows and columns. Each row represents a record, while each column represents a specific attribute or field. This structure makes it easy to search, sort, and manipulate data. The tabular format is not only intuitive but also highly efficient for handling large volumes of information. Let's look closer at how tables work in practice. Tables are the fundamental building blocks of traditional databases. Each table is designed to store data about a specific topic, such as customers, products, or transactions. Within a table, each row is a unique record, and each column holds a particular type of information, like a name, date, or price. This clear separation of data types helps maintain order and consistency. By organizing data into tables, databases can quickly retrieve and update information as needed. Now let's see how relationships between tables enhance data management. Traditional databases often use relationships to connect different tables. These relationships allow data to be linked across tables, making it possible to combine information in meaningful ways. For example, a customer table might be linked to an orders table so you can see which customers placed which orders. Relationships are typically established using keys, unique identifiers that connect records across tables. This interconnected structure supports complex queries and reporting, making databases powerful tools for analysis. Next, we'll discuss the types of keys used in databases. Keys play a crucial role in maintaining the integrity of a database. A primary key is a unique identifier for each record in a table, ensuring that no two records are the same. A foreign key, on the other hand, is a field in one table that links to the primary key of another table. This connection enforces relationships and ensures data consistency. By using primary and foreign keys, databases can prevent duplicate records and maintain accurate links between related data. Let's move on to how data is actually stored within these tables. Traditional databases, data is stored on physical storage devices like hard drives or solid-state drives. The Database Management System (DBMS) handles the organization, retrieval, and updating of this data. Data is typically stored in files, which are managed by the DBMS to ensure quick access and reliability. The DBMS uses indexing and caching techniques to speed up data retrieval, making sure users can access information without delay. This efficient storage system is one of the reasons why traditional databases remain popular for many applications. Database Management System, or DBMS, is the software that interacts with end users' applications and the database itself to capture and analyze data. Popular DBMS examples include MySQL, Oracle, and Microsoft SQL Server. The DBMS provides tools for defining, creating, maintaining, and controlling access to the database. It ensures that data remains secure, consistent, and available when needed. By managing how data is stored and accessed, the DBMS is a critical component of any traditional database system. Structured Query Language, or SQL, is the standard language used to interact with traditional databases. SQL allows users to create, read, update, and delete data using simple commands. With SQL, you can define tables, insert new records, search for specific information, and generate reports. Its straightforward syntax makes it accessible to both beginners and experienced developers. SQL's power and flexibility have made it the backbone of database management for decades. Next, let's see how SQL works in practice. Let's look at a simple example of using SQL to create a table. Suppose you want to store information about books in a library. Using SQL, you can define a table with columns for the book's title, author, publication year, and ISBN. This structure ensures that every book record is organized and easy to retrieve. By specifying data types for each column, you help the database maintain consistency and prevent errors. This process is fundamental to setting up any traditional database. Every column in a database table has a specific data type, such as integer, text, date, or Boolean. Data types help the database understand what kind of information is being stored and how to process it. For example, a date column ensures that only valid dates are entered, while a numeric column prevents text from being stored by mistake. Choosing the right data types is essential for data integrity and efficient storage. Let's move on to how databases keep data safe and consistent. Data integrity means making sure that the information in the database is accurate and reliable. Traditional databases use various rules and constraints to enforce data integrity. For example, unique constraints prevent duplicate entries, while not null constraints ensure that important fields are always filled in. Foreign key constraints maintain consistency between related tables. These measures help organizations trust the data they rely on for decision-making. Next, let's discuss how databases handle multiple users accessing data at the same time. Environments where many users access the database simultaneously, concurrency control is vital. This ensures that multiple operations can happen at the same time without causing conflicts or data corruption. Traditional databases use techniques like locking and transaction management to handle concurrent access. For example, if two users try to update the same record at once, the database ensures that changes are applied in a controlled way. This keeps data consistent and prevents errors, even under heavy usage. Transaction is a sequence of operations performed as a single logical unit of work. In traditional databases, transactions ensure that either all changes are applied or none are, maintaining data integrity. This is known as the all-or-nothing principle. Transactions are especially important for critical operations like transferring money between bank accounts. If something goes wrong during a transaction, the database can roll back changes to prevent inconsistency. Let's explore the properties that make transactions reliable. Traditional databases follow the ACID properties to guarantee reliable transactions. ACID stands for atomicity, consistency, isolation, and durability. Atomicity ensures that all steps in a transaction are completed or none at all. Consistency means the database remains in a valid state before and after the transaction. Isolation ensures that transactions don't interfere with each other, and durability guarantees that once a transaction is committed, it won't be lost. These properties are the foundation of trustworthy data management. Indexes are special data structures that help databases find information quickly. Think of an index like the table of contents in a book. It points you directly to the information you need. By creating indexes on important columns, databases can speed up searches and queries, especially in large tables. However, indexes also require storage space and can slow down updates, so they must be used wisely. Next, let's look at how databases back up and recover data. Protecting data from loss is a top priority for any organization. Traditional databases offer backup and recovery features to safeguard information. Regular backups create copies of the database that can be restored in case of hardware failure, accidental deletion, or other disasters. Recovery tools help bring the database back to a consistent state after a problem. These features ensure that valuable data is never permanently lost, providing peace of mind to users and administrators alike. Security is a critical aspect of database management. Traditional databases use authentication, authorization, and encryption to protect sensitive information. Authentication verifies user identities, while authorization controls what actions users can perform. Encryption scrambles data so that only authorized users can read it. These security measures help prevent unauthorized access, data breaches, and other threats. As data becomes more valuable, robust security is more important than ever. While traditional databases are powerful, they can face challenges when scaling to handle very large amounts of data or high numbers of users. Scaling up often requires more powerful hardware or complex configurations. Some databases can be distributed across multiple servers, but this adds complexity. As organizations grow, they must carefully plan how to scale their databases to meet increasing demands. Let's see how traditional databases compare to newer approaches. Recent years, NoSQL databases have emerged as alternatives to traditional databases, especially for big data and real-time applications. Unlike traditional databases, NoSQL systems often use flexible data models, such as documents or key-value pairs instead of strict tables. This flexibility can make them better suited for certain types of data and workloads. However, traditional databases remain the go-to choice for structured data and complex transactions. Each approach has its strengths and weaknesses. Traditional databases are ideal for applications that require structured data, strong consistency, and complex queries. Examples include banking systems, inventory management, and enterprise resource planning. These systems rely on the reliability and robustness of traditional databases to ensure data accuracy and security. When data relationships are important and transactions must be processed reliably, traditional databases are often the best choice. Let's look at some real-world examples. Banking systems are a classic example of where traditional databases shine. They require precise tracking of transactions, balances, and customer information. The ACID properties of traditional databases ensure that every transaction is processed accurately, even in the event of system failures. Security features protect sensitive financial data, while backup and recovery tools guard against loss. These capabilities make traditional databases a trusted choice for the financial industry. Inventory management systems rely on traditional databases to keep track of products, stock levels, and orders. The tabular structure makes it easy to organize and update inventory data. Relationships between tables allow for efficient tracking of suppliers, shipments, and sales. By using indexes and queries, businesses can quickly find out what's in stock and what needs to be reordered. This efficiency helps companies avoid shortages and overstocking. Enterprise resource planning, ERP systems integrate various business processes, such as accounting, human resources, and supply chain management. Traditional databases provide the structured environment needed to manage this complex data. By supporting multiple users and transactions, they help organizations coordinate activities and make informed decisions. The reliability and scalability of traditional databases are key to successful ERP implementation. Healthcare organizations depend on traditional databases to store patient records, appointment schedules, and billing information. The structured format ensures that sensitive data is organized and accessible to authorized personnel. Security features protect patient privacy, while backup and recovery tools help maintain data availability. Accurate and timely information is critical in healthcare, making traditional databases a vital part of the industry. E-commerce platforms use traditional databases to manage product catalogs, customer accounts, and order histories. The ability to handle complex queries and transactions is essential for processing purchases and tracking shipments. Security features protect customer data, while scalability options help businesses handle peak shopping periods. Traditional databases provide the reliability and performance needed for successful online stores. Educational institutions and research organizations use traditional databases to store student records, course information, and research data. The structured format allows for efficient organization and retrieval of information. Security and backup features ensure that important academic and research data is protected. By supporting complex queries, traditional databases help educators and researchers analyze trends and outcomes. Governments rely on traditional databases to manage records such as tax information, licenses, and public services. The structured approach ensures that data is organized, secure, and accessible to authorized personnel. Backup and recovery features protect against data loss, while security measures prevent unauthorized access. These systems are essential for delivering reliable public services and maintaining transparency. Telecommunications companies use traditional databases to manage customer accounts, billing, and network operations. The ability to handle large volumes of structured data and process transactions quickly is essential for delivering reliable services. Security and backup features protect sensitive customer information, while indexes and queries enable efficient data retrieval. Traditional databases help telecom companies maintain high levels of service and customer satisfaction. Media companies use traditional databases to organize content libraries, manage user subscriptions, and track viewing habits. The structured format supports efficient storage and retrieval of large media files and metadata. Security features protect intellectual property, while backup tools ensure content is not lost. By supporting complex queries, traditional databases help media companies analyze audience preferences and deliver personalized experiences. Travel agencies and hospitality businesses use traditional databases to manage reservations, customer profiles, and billing information. The structured approach ensures that bookings are accurate and customer preferences are recorded. Security and backup features protect sensitive data, while indexes and queries enable quick access to reservation details. Traditional databases help these businesses deliver smooth and personalized customer experiences. Retailers use traditional databases to manage inventory, sales, and customer information. The tabular structure makes it easy to track products, monitor sales trends, and analyze customer behavior. Security features protect sensitive data, while backup and recovery tools ensure business continuity. By supporting complex queries, traditional databases help retailers optimize operations and improve customer service. Manufacturers rely on traditional databases to manage production schedules, supply chains, and quality control data. The structured format supports efficient tracking of materials, processes, and finished goods. Security and backup features protect sensitive business information, while indexes and queries enable quick access to critical data. Traditional databases help manufacturers maintain high standards and streamline operations. Logistics companies use traditional databases to manage shipments, track vehicles, and monitor delivery schedules. The structured approach ensures that all aspects of the supply chain are organized and accessible. Security and backup features protect sensitive data, while indexes and queries enable efficient tracking of shipments. Traditional databases help logistics companies deliver goods on time and maintain customer satisfaction. Energy companies use traditional databases to manage customer accounts, billing, and usage data. The structured format supports efficient organization and retrieval of information. Security and backup features protect sensitive data, while indexes and queries enable quick access to usage records. Traditional databases help energy companies deliver reliable services and respond to customer needs. Real estate companies use traditional databases to manage property listings, client information, and transaction records. The structured approach ensures that all data is organized and accessible. Security and backup features protect sensitive information, while indexes and queries enable efficient searches. Traditional databases help real estate professionals match clients with properties and streamline transactions. Nonprofits use traditional databases to manage donor information, track fundraising campaigns, and monitor program outcomes. The structured format supports efficient organization and reporting. Security and backup features protect sensitive donor data, while indexes and queries enable quick access to campaign results. Traditional databases help nonprofits achieve their missions and demonstrate impact. Scientists use traditional databases to store experimental data, manage research projects, and analyze results. The structured approach ensures that data is organized and accessible for analysis. Security and backup features protect valuable research data, while indexes and queries enable efficient retrieval. Traditional databases support collaboration and help researchers make new discoveries. Libraries use traditional databases to manage catalogs, track borrowed items, and organize member information. The structured format supports efficient organization and retrieval of books and resources. Security and backup features protect member data, while indexes and queries enable quick searches. Traditional databases help libraries serve their communities and manage resources effectively. HR departments use traditional databases to manage employee records, payroll, and benefits. The structured approach ensures that sensitive information is organized and accessible only to authorized personnel. Security and backup features protect employee privacy, while indexes and queries enable efficient searches. Traditional databases help HR professionals manage the workforce and comply with regulation. ERM systems use traditional databases to manage customer interactions, sales leads, and support tickets. The structured format supports efficient tracking and analysis of customer data. Security and backup features protect sensitive information, while indexes and queries enable quick access to customer histories. Traditional databases help businesses build strong customer relationships and improve service. Project management tools use traditional databases to organize tasks, track progress, and manage team collaboration. The structured approach ensures that project data is organized and accessible. Security and backup features protect sensitive information, while indexes and queries enable efficient tracking of milestones. Traditional databases help teams stay on schedule and achieve project goals. Content management systems, CMS, use traditional databases to store articles, images, and user information. The structured format supports efficient organization and retrieval of content. Security and backup features protect valuable data, while indexes and queries enable quick searches. Traditional databases help CMS platforms deliver content to users and manage websites effectively. Sum up, traditional databases provide a structured, reliable, and secure way to store and manage data. Their tabular format, robust transaction support, and strong security features make them ideal for a wide range of applications. While newer technologies offer alternatives, the core principles of traditional databases remain relevant and valuable. By understanding how data is structured and stored, you can appreciate the role these systems play in our digital world. Let's wrap up with some final thoughts. Traditional databases have stood the test of time, providing the foundation for countless applications and services. As technology evolves, these systems continue to adapt, incorporating new features and supporting larger, more complex datasets. While alternative approaches like NoSQL are gaining ground, the structure and reliability of traditional databases ensure they remain a vital part of the data landscape. By mastering these concepts, you'll be well equipped to work with data in any field. Thanks for joining us on this exploration of traditional databases.